Hi students, welcome to Physics. This is the first lesson of physics in 12th class, that is electrostatics. Actually, electrostatics is a branch of electricity. Electricity has two branches, that is, first one is static electricity and second one is current electricity. And static electricity deals with the stationary charges, so that is coming in our lesson electrostatics. The current electricity, it deals with the charges which are flowing. The electricity created due to flow of charges, and that you already studied in 10th standard, and again it is coming as the second unit in 12th class. So in our today's discussion, we will be focusing on static electricity. The history of this discovery of static electricity, it is in 600 BC. In 600 BC, the person called Thales of Miletus in Greece, he discovered the phenomena of static electricity, that is from the material called amber. Actually, the word electricity, electron, electronics, the root word came from electron. Electron is the name of amber in Greece. Amber means it is when we cut the bark of a wood, we will get a sap, a jelly-like material. When it is dried in sunlight, you'll get a transparent substance that is called electron in Greece, and its English word is amber. Sometimes we use it for fuming, for getting good smell and all. And this person, Thales of Miletus, he observed that when this amber is rubbed with some material, and then it can attract small dry pieces of grass and all. So that shows that there is some property of attraction, and this was the first observation of Thales of Miletus, and that observation leads to the discovery of static electricity. And afterwards, the word electricity, electron, and all came from the word electron. Actually, electron is the name of the amber, that dried sap of wood in Greek. Okay. Now, in our lesson, the electrostatics, the first topic is electrification. How to make a body charged, that is electrification. And electrification, we have three different methods, that is charging by friction, by conduction, and by induction. And charging by friction can be done only in insulators, like glass rod. When we rub with a silk, electrons will be transferred from glass rod to silk. So the glass rod, since electrons are lost, will become positive charge, and the silk will become negatively charged because of the gain of electron. And charging by conduction means that is possible only in metallic substances. If two metallic spheres are brought in contact, if one is charged, the other is not charged, the charges will flow each other between the conductors, and the resultant charge will be the average of the two. So we have three different methods of charging a body: by friction, by conduction, and by induction. By induction means bringing a charged body near to a uncharged body, close to it, so that it will become charged. The next topic is the basic properties of electric charges. The main properties of electric charges are, the first one is like charges repel and unlike charges attract each other. So already we know this concept. Positive charges and positive charge will repel, or negative and negative will repel, and positive and negative will attract. The second basic property is charges are quantized. Charges are quantized means charges can be always an integer multiple of basic unit of charge, that is the charge of an electron. Charge of electron, all of you know, it is 1.6 into 10 to the minus 19 coulomb. Coulomb is the SI unit of electric charge. So when we charge a body, either negative or positive, it can have charges 1 times, 2 times, 3 times the charge of electron. Means it cannot be a fraction. So charges are quantized means the total charge on a body can be a multiple of integer multiple of the basic unit of charge, that is charge of an electron. Then third property of charges is charges are conserved. Charges conserved means the total charges in an isolated system will remain constant, means as usual charges can neither be created nor be destroyed. And you know, basically the charges, positive and negative charges, are carried by protons. Positive charge is carried by protons in the nucleus, and negative charge by electron, which is revolving around the nucleus. And these fundamental particles we cannot create or destroy, so the charges cannot be created or destroyed. And the last property, the fourth property, is charges are additive. The additive means the total charges can be added together, just like a numeral. For example, if we have charges on different bodies, Q1, Q2, Q3, etc., when we combine all this together, the total charge will become Q1 plus Q2 plus Q3, etc. So that add together just like a real number, and because of that we can say charges are additive. Now, the first important topic in this lesson is the Coulombs law, as the first fundamental properties, the basic properties of charge we have seen here. That is, like charges repel and unlike charges attract. So that is the main property of charges. Like charges repel and unlike charges attract. So between the charged bodies, there will be a force of either attraction or repulsion, and that force is governed by Coulombs law. According to Coulombs law, if there are two charged bodies with the charges Q1 and Q2, and if they are separated by a distance between them, then the force between the two charges is directly proportional to product of the two charges and inversely proportional to the square of the distance between the two charges. That is what is the statement of Coulombs law. Now we'll discuss in detail the Coulombs law in electrostatics. So according to Coulombs law, suppose we have two charged bodies. So this is one charged body, this is another charged body, and they have charges. Suppose this one is having charge Q1 and this is having charge Q2, and they are separated by a distance between them. Say R is the distance between them, between the center of the two bodies. Then according to Coulombs law, suppose both of these are positively charged bodies, so there will be a force of repulsion between them. Say F is the force of repulsion between them. According to Coulombs law, this force F between the two bodies is directly proportional to the product of the two charges, Q1 into Q2, and it is inversely proportional to the square of the distance between the two charges, that is R square. So this law is just like the Newton's law of gravitation that we studied last year, isn't it? In Newton's law of gravitation, if there are two masses m1, m2, and separated by a distance r between them, the force of attraction between two masses directly proportional to m1 into m2 and inversely proportional to r squared. Same like that here, instead of mass it is q1 and q2. So F proportional to q1 q2 by r square. Then when we convert this proportionality into an equation, F is equal to, it become there should be a constant of proportionality, that is k into q1 q2 divided by r square. This proportionality constant k, its value is given by k is equal to 1 by 4 pi epsilon naught if the two charges are placed in vacuum or air. In this value 1 by 4 pi epsilon naught, this quantity epsilon naught is called permittivity. It is called permittivity of free space. Free space or vacuum, permittivity of free space. its value is epsilon naught is equal to 8.85 into 10 to the power minus 12 Coulomb square per Newton meter square. It's a constant for free space or vacuum. It is, for air also it is taken as almost same, 8.85 10 raised to minus 12 Coulomb square per Newton meter square. That is a value of epsilon naught. So if you substitute the value in this equation, the 4 and pi value 3.14 and epsilon naught 8.85 10 raised to minus 12, we will get the total value of the constant K is equal to 9 into 10 raised to 9. That will come in Newton meter square per Coulomb square. Newton meter square per Coulomb square per Coulomb square. So this is the equation which gives the force of attraction or repulsion between two charges when they are placed in vacuum or air. If the two charges are placed in a medium, then the value of constant K will be different. That time the K value is given by K is equal to 1 by 4 pi epsilon naught into epsilon r. Here this quantity epsilon r is called relative permittivity. Okay, only epsilon naught is permittivity of free space. Epsilon r is the relative permittivity of a medium, and the relative permittivity means it is epsilon r. It is the ratio between the absolute permittivity of a medium to permittivity of free space. It is also called dielectric constant K. So epsilon r can be also written as K. It is also called dielectric constant. So the value of K or epsilon r is epsilon divided by epsilon naught. So when we, from this equation, the absolute permittivity epsilon of a medium can be written as epsilon naught into epsilon r. So the value of K, 1 by 4 pi epsilon naught and epsilon r, it came from the definition of relative permittivity, that is the ratio between absolute permittivity of a medium to the permittivity of free space. So according to Coulombs law, the final equation of Coulombs law we can write like this, that is the force between two charges F is equal to K into Q1 Q2 by divided by R square. That can be also written as F is equal to 1 by 4 pi epsilon naught into epsilon r into Q1 Q2 divided by R square. This is the final equation of Coulombs law that can be applied for any medium other than air or vacuum. If it is air or vacuum, then epsilon r is not needed, only epsilon naught is needed. If it is any other medium like water, oil, some other medium, there will be the constant epsilon r also, that is different for different media. It depends on the medium, epsilon r value. And epsilon naught is it's for only vacuum, that is always 8.85 into 10 raised to minus 12. So this Coulombs law gives us the basic idea about the force acting between charges or charged bodies in electrostatics. Okay, we'll continue in next class. Thank you.